Good morning, everybody. For those of you who don't know me, I'm Amy Boyer. I'm the engineer with ODA for areas 3 and 5, and I think we will get started here. So let me share my screen. Can everybody see that okay?
I can see it, Amy.
Okay, so I think before we get started with the actual running of the engineering tools, we want to kind of go and talk about a little bit of the compatibility issues and the needs of this program. So I just went to the website and looked at some of the hardware requirements to run. Obviously, versions 10.6 and 10.7 are requiring the same thing. I know that 10.8 is out there as well. I did not look that one up. But this is the bare minimum that they're requiring that you have. And I know we've had a lot of issues with people saying that their ArcMap is running very sluggishly, and it may be because you just don't have a computer that can run it as, maybe it should or be quite as fast. I know Justin McBride a couple years ago put together a sheet of computer needs that we think people should have to run both ArcMap and AutoCAD, and we can get that out to you sometime if anyone is in need of that. But the one thing that we really want to highlight here is maybe the things that are most important. So we have the speed, so the CPU speed there. If we're going to put our money into something, that's probably one of the things that we want to put the most money into. Faster is better. Just think of these programs kind of as a video game. We do need a gaming quality computer to make these things run very quickly and efficiently. One of our recommendations was, it's saying for that would be a 2.2 minimum. We were recommending probably going to that 3 or 4, so a little bit higher than that. Another thing that we would recommend would be with your RAM. It says it's recommending an 8 or higher. We would also recommend that as well. And then when it comes to storage, it's obviously, are you storing your files on your hard drive? Are you storing them on a server? When we get to some of those new aerials that you can get off the OGRIP site, those are very, very large. They take up a lot of storage space. So wherever you're putting that information, we really need to have enough storage to be able to accommodate that. We also have the operating systems. I'm assuming everybody who is running ArcMap has an operating system that is going to work appropriately. One of the things we really need to think about, and I know we just had the 2.0 version of the engineering tools released by NRCS, and we've had some issues. So we need to make sure that our version of ArcGIS, ArcMap, and our version of the engineering tools are compatible with each other. I know most people with the district, I think, are running 10.6 right now. We do have the ability to get people 10.7, although that is a very large file, and we've had some issues being able to distribute that. If you are running on one of those, you can run the new version of 2.0. I will give you warning, we have had a lot of problems with the 2.0 version. If you're running 10.6 or lower with that 1.1.15 that I think most people are running right now should work appropriately. NRCS did inform me that if you are one of those districts that's running ArcMap Pro, then the engineering tool will not work on any version of that. So FYI to those people. Also, the NRCS staff now has access to ArcMap or ArcGIS 10.8. So if you're on a CCE machine, you do have the ability to download that newest version. 2.0 is not working properly on that. They are waiting for an upgrade to be released. So hopefully a lot of the issues with that 2.0 will go away when we get a new upgrade, but I'm not sure when that's going to be. I guess that said, if it's working, let's not change it. I tried the 2.0 version on my own computer the other day and was not very successful. Lindsay, ironically, I forwarded Lindsay the 2.0 version. She has the same version of ArcMap and it ran perfectly on hers. So I'm not sure what the issue is. To get that Arc toolbox, I know we went over this a couple months ago. We need to click on that little red toolbox up at the top of your screen. And then it'll pop up the box onto the side of your computer. You click on the ArcMaps and then just navigate to wherever you have saved that version. You can see I have many versions on my computer. That might be my issue, I don't know. And again, one of the things we want to do is we want to hit that Customize tab at the top of our computer and select the extensions. We need to make sure that all of those are checked, that we can have checked, because if they're not all checked, all the functions of the ArcMap engineering tools may not work properly and may not be working for you. So that's very important step to not forget. Depending on the version of ArcGIS you have, you may not be able to check all those boxes. Everything that I have checked here is checkable if you have a version distributed by NRCS. So we were trying to really look to see what are the differences in the versions between that 1.1.15 versus that 2.0. I was assured by the NRCS state office that there are absolutely no differences within the watershed tools, which is what I think the majority of us are using. There are some changes within the utility versions. I will be the first to admit I do not know what all of those do. But Lindsay, I think, has played with a couple of those, and she's going to show you how to merge using the Arc engineering tools versus the way that we did last time. And that may be a little bit quicker for some people. So I got stuck on the very first step when I tried to load version 2.0. I was trying to define my area of interest, and it failed to execute on the very first try. And then being an engineer, I decided to play some more. So I went back to my 1.15. I defined my area interest. It ran perfectly fine. So then I thought I'll go back to 2.0 and go to step 2. It crashed my computer, so that may not be the thing to do. Other errors, I know we had someone from Northwest Ohio had sent me this error the other day. And this is an error that's going to be due to somehow things are not in the right location. I know we've discussed that ArcMap can be picky of where things are saved. So we do really need to make sure that we're saving things appropriately and putting things where they need to be. And we're going to go into that in a little further detail when we talk about saving when we're running those Arc engineering tools. And I am going to hand this over to Lindsay because her computer meets those specs a little bit more than my current computer does, and it runs it a little bit better. Let me get out of here. Have I stopped sharing? I think I have stopped sharing here.
Actually, I'm still muted. Okay. All right. Hello, everybody. My name is Lindsay Douglas, and I've been a CET for NRCS for about 3 years. So I've dabbled with this quite a bit, and I'll try and share with my screen here, and we'll figure this out. Okay. Can you see me? Are you good? Okay. So I already have a map set up here. I have most of my things saved on an external hard drive or on my C drive. It tends to work a little bit better, especially working from home. It tends to work a lot faster that way. Things that I already have added to my map are I've got my background aerial. I've already added the DENs that I would have downloaded from the OGRIP website. I have a clue layer. I know not everybody has access to that. I think the different FSAs have kind of different feelings about sharing that information. I also have the soils for this county that have the hydrology definition attached to it. I also have roads and just some things that will help me locate. Another helpful thing is you can download this from the OGRIP website. Is it will tell you the tiles, the name of the tiles to download. And then I also have a bridges and culverts layer. Some of you may be able to access this from an engineer's office, or you may have it already in your office, and it just tells you where certain bridges and culverts are located along roads. We will need that here in this process. If not, you can zoom in and kind of give your best guess. But I will go ahead and start. So I chose this location, and I would just do add data normally to add these on here, but I already added them. So I'll turn them on. So in order for this to work, we need all of these to be combined together. You can't run the tool with them individual. It just won't work properly. So Amy had mentioned that there were some new differences in the new version. Here is one of them, and it's called Clip and Merge Adjacent DEMs. I've run this once and had success. So I'll go ahead and run it again. But the other way to do this is you will go to your toolbox called Data Management Tools, and then you'll go down to rasters, raster data set, and then you'll run the mosaic to new raster. And this is what it looks like. You'll just input these, find a location to save them. You'll select the correct information, which I believe is 32-bit float, and the bands would be 1. And then it will run it for you and merge them. But we'll try something new today. Hopefully it works. So we'll run this clip and merge adjacent DEMs. So when working with the Watershed tool, it can be really picky on your file locations. I highly recommend saving all your files to your C drive, because I know with NRCS, our server locations have a lot of special characters in them, like, and it doesn't like those. Also spaces, it doesn't like spaces. So what I do is I always pick my saving location to be on my C drive, and I have a watersheds folder, and then I'll make a new folder that's for today. Actually, I already have one made here. It's GIS training. Say add. And it will chug. This is very classic for GIS. It will take some time. Try to be patient and not click too much, because it tends to bog it down even worse. So then the next step is you'll enter your area of interest. So I know I want to be for this waterway here. I want to find the watershed for it. So I know that this is going to be outside of my reach. So I'll just make a box here. And then I'm going to here add the rasters that I'm trying to put together. You can click and drag them like I just did from your table of contents, or you can do the drop down, or you can find them if they're in a file if they're not already on your map. I like the click and drag because I'm just more efficient that way. You hit OK, and it will render. These boxes are a good sign. You can hide the details, or I like to see what's going on in case there's any error messages. This will take a minute. Most of these steps take a few minutes, especially if you have really large watersheds. They can take quite a bit of time. Seems to be running smoothly. So it said it successfully merged 4 rasters. The DEMs are also known as a raster. This is the new information it produced. So it gave me, here, I'll turn off my old ones. It gave me the new merge DEM, which was the color, the bright rainbow colors. And it also gave me this area of interest, which I can turn on and off. So now this is what we will be working with for our next steps. So you'll open up your toolboxes again and go down. So we'll go out of utilities now, and we can go into our watershed tools and then watershed delineation. We're going to define area of interest again. Now, the first time I ran this, I did try to pull over this old area of interest I made, and it didn't really work. I don't know if that was just a glitch or if I did something wrong, or if the program doesn't like it, but it's probably just good practice to make a new area of interest based on for the watershed. So I'll select a new workspace, and then I'll add my new DEM that just, our merged DEM that was made. And then this is something new on the 2.0 version. We do need to select what units we're using. So here we're using feet, and I'm going to go ahead and draw a new area of interest, and it kind of snaps to the old one. So, okay. And then if you want to do contours, you can select what you want that. You can do 1/2 foot, 1 foot, 2 foot, 5 foot, and 10. A lot of times I do 1 foot and hit OK. And that's just optional. You don't have to do that. If your computer tends to run slowly, I would probably skip that just so that it will run a little faster. When you see it running like this, that's always good signs. It's kind of telling us what it's doing there in the box. So it's creating hill shade, and that's a feature that kind of makes it look 3D. It'll also do a depth grid, which will kind of show where water ponds. Okay. So we got a lot going on here. This is all stuff you can turn on and off. So I still have my merged DEM on the background, but it made a new one with the watershed tool. So I can also turn that one off. But you see how it has the 3D look? That's the hill shade. Our depth grid is the blue little ponds here and there. And then we've also got our contours here. So I like to turn them off so I can see what's going on, see where I'm trying to focus on a little bit better. One thing that I do turn on and off a lot is this depth grid. If I don't have a lot of good culvert information. Here I do, and luckily actually I don't really have any culverts that affect this waterway. I have one up here and one down here, but they're not directly in the path. So move on to our next step, which is create stream network. And this is where the culverts will really come into play. So we're selecting the area of interest feature again. So make sure you pick your one you made for the watershed tool. If you feel like you're going to get confused, you can always just remove the DEM one. It's probably safest. And it's not deleted, it's just not on your map currently. So then I'm going to digitize any culverts. Like I said, there's not any that are directly in line with this, but I'll go ahead and draw in the others. So you can see that it's ponding over here. If we weren't to draw this in, it probably wouldn't cross the road. But we know since this is here that it needs to cross the road. Find another one. This is a good step to take your time on. Make sure that you're not missing anything. Even driveway culverts can affect things like here. Here's a good example. This is probably a culvert under a driveway. So if this was in the watershed for your waterway, you would definitely want to add a culvert there. But since it's not part of the roads culvert system, it did not show up. And I think that's probably sufficient. And then I usually leave this as default, this the threshold, and then you just hit OK. And what this is doing is it's trying to figure out where the water's flowing, and it will draw on stream networks onto your map. So far, so good. Everything's running pretty smoothly. This doesn't happen for everybody. Sometimes it'll throw an error or crash your computer. So we've had quite a few people ask us about that. And it's not always the same things. Some things that affect that are, if you had a bad internet connection and you were trying to work off of some file that was on the server, and that can throw it off. Or you have a file location that has a space in it. It doesn't like those for some reason. So and sometimes this step will take a minute. It's normal. So these boxes are good to just kind of scroll through sometimes while you're waiting, and you can see it kind of tells you what it's doing, which is kind of cool. Looks like it's moving forward again. Like I said earlier, the bigger the watershed, the longer it'll tend to take to render all of this. But that's the nice feature about the new clip merge for the DEM, is that you're not stuck working with a giant DEM that's bigger than you need it to be. And you don't have to make it into squares. You can make it into irregular shapes, your area of interest, when you're merging the DEMs, and that can cut down a lot on what the computer has to process. So that was something actually I was really excited about with this new version. So you can see it added these blue lines, and it's good to kind of check them over, especially if you're familiar with the area and you see something weird that doesn't look right, it's not flowing right. You might need to check and make sure you didn't forget to add a culvert or something like that. This program only is as good as the information you give it. So if you don't have a really good DEM to work off of or anything like that, it can be difficult to get a good product from it. But here you can see, because we drew on this culvert, this blue line now crosses this road. And then there's up here, go look at the other one. So now this crosses this lane, and it may, if you didn't remember to add that, it may still cross, but it might show it coming down here and then crossing over back. And if it's not on your direct path, it's not the end of the world, but it's good to add those in because it can sometimes affect the one you're directly working on. Okay, so we'll move to the next step, creating watershed. So now here it's asking us to add our stream network. So we'll go over here, add that, And then we're going to digitize where our outlet is. So on this one, I'm going to scroll down here. And what you need to do is bisect the blue line that is in your stream network. Otherwise, it won't draw a proper watershed. And then we're going to give it a name, and I'll call it WA for Waterway A. And here's an option down here to create a watershed flow path. If you have a computer that tends to struggle with GIS in general, I would probably recommend not selecting this and calculating it manually, because it would just be a straight line measurement. Because this can really bog down some computers. My computer doesn't seem to have an issue with it, so I'll go ahead and select it. Okay. So get to wait again. This one should run a little bit quicker than your stream networks. In my experience, I feel like the stream networks tends to be the slowest step. And you can actually do more than one watershed at a time. The only thing I've had issues with is nested watersheds. So if you had a watershed and then a branch within that watershed, I would run them separately because it subtracts the acreage of the branch from the main waterway. So you would have to add them together to know the actual acreage. But if they are completely separate, it works fine, as long as you aren't doing a very large watersheds and a lot of them. It may just take a long time. I normally just run one at a time. So here it's calculating the watershed flow path, which is the option I selected. So if your computer has trouble, this is something that can take a long time. You could even see that mine takes a little bit longer to get through that step. If your computer is really slow, this is when you get up and walk around your office for a second, go find a snack. So something that's nice about this tool is it does a lot of the work for you, as in calculating your average watershed slope that you'll use to figure out your runoff. And then you can make a nice map out of it too. Versus delineating it by hand, you kind of, at least in my experience, it's not always super accurate trying to figure out what the average watershed slope is. So here's our product here. So the red line on the outside is our watershed, and the blue and white dotted line is our longest flow path. So that's the longest route a drop of water has to take before it gets to the outlet. These are all things that you will need when you calculate your runoff. So here, it automatically calls them subbasin 1, unless you're doing multiple of them, and then it'll give you your acres and your average slope. When I make maps, a lot of times I'll go in and edit these so that, it says for waterway A, and then a lot of times I'll go ahead and add the length of the flow path. To find the length of the flow path, you can just come over to that layer here in the table of contents, and you can open the attribute table and it will tell you the length right here and also here. But and then you can add that if you want to, or you can leave it this way and just add it to your runoff sheet. So some of you, this will be a place you can stop. Especially if you don't have a really good clue layer or any really good soils information, you can still make a really good map out of this that will help explain, what you're working with. But for those of you who do have soils information at the minimum, and especially if you have clue layer information, we'll go on to the next step. There is a step 4, update watershed attributes. I normally do not use this unless I edit the edge at all, the shape of the watershed. So sometimes you've got goofy things going on that that's not how things flow. If you're familiar with the area, you can go in and edit this. If you do, you will need to run the step 4. It will update your acreage and everything based on the new line. 99% of the time, I never use this tool. But we'll go on to the prepare soils and land use, which is part of our runoff curve number section. So here we will input our new watershed layer, and then we will put in our soils layer, and it has to have the hydraulic units attached to it. So mine has, here's where I select what column in the attribute table that is located, and mine's under hydraulic group DC. Some of them are different. Most of them are like that if you've got them from NRCS. And then I'm lucky enough to have the clue layer, so I go and I add that. And that's just optional. You do not have to have that to run this, but it's helpful. You say, okay. You wait another minute. These tend to run a lot faster. So some of these filled in with their soil types and some of them didn't, and that's because they may have 2 options. So a lot of times if the soil is drained, we use the lesser runoff number. And in order to edit this to run to the next step, we have to start editor. Some of you will not have this toolbar automatically on your toolbar up here. You'll have to go to customize toolbars, and then you select the editor toolbar and it will appear. So we go to editor, start editing, and then we have to go to our waterway A soils, say okay. It'll warn you that you may be able to manipulate any of these other layers, but you just continue. So now if I open up the attribute table for our soils, you can scroll over to the side, and anything that has multiple letters, we need to select one. So if you select it over here to where it's blue, you can also go zoom to layer and see where it is. So we see it's here, it's drained, because you can see the tile lines. So I'm gonna pick C for this. And for sake of time, I'm just going to go ahead and do C for all of these, but you would go on each one and kind of look and see where it is and make a determination. And it's good practice to go ahead after you've edited everything here. You just go ahead and say save edits. I wouldn't stop editing though, because we also need to edit our land use. So here's, if you have your clue layer, this is where it comes in handy. So it's black lines, but you can see that where borders changed based on the clue layer, and you're going to decide what type of land use that is based on those blocks. So I'll go ahead and open that attribute. And you can do the same thing. So you'll select over here and right click and say zoom to. You make a determination based on this. So this looks like it's some housing. Also got road. If you have more than one option that you know, okay, these are really different, they need to be broken apart, you can do that. And I use the cut polygon tool when I do this. And what you do is you click on it and you click on the next side and it breaks it in half. It's a good shortcut. I won't do that for sake of time for every single piece here, but we'll go ahead and go through. So for this one, I'll just do residential. It's easier if you expand this so you can see the whole thing. So here's all the options, and these correlate to the runoff program. So I'll say residential 2 acres just for this, and its condition is good. Most of this, though, is row crop. And for sake of time, again, I'm just going to go ahead and do the same for all of these. But like I said before, you'll go through and select actually what that land use is. It can be a little tedious, but it does make a nice map when you're finished. And that's kind of the advantage to using this over hand drawing things. And also you can print off some information that it just kind of proves everything that you're working on. And then most of the time the condition is good, so we'll go ahead and, but if you know if there's issues, you can select different options here. But for sake of time, I'll just do good. Okay, and again, we'll say save edits. You have to hit stop editing for this next part. So now we've selected our soil types and our land uses. Then we can move on to our next step, calculate runoff curve number. So here we're going to put in our watershed that we made before, and it knows, since it's all under the same project, that these soils and land uses are attached to this watershed. We hit OK. It's going to run for a second. It's nice when it says all populated correctly. Okay, so not much change to your map, but it did add this RCN, Waterway ARCN layer here. And it is on there. It just, since I have everything like the same land use and soil type, it didn't really show a big difference except for right here where I changed it to residential. There will be different lines. There's ways to manipulate this. You can open the attribute table, and it gives you your acreage based on your soil type and land use. And this is what you'll use to plug it into the runoff curve number program that we used for waterways. And then you can also manipulate how it looks. We're going into the properties, and you can change to unique values for land use, add the values, and they'll show up in different colors. They're always really random. You can change these by selecting this box and going there, but for sake of time, I won't do that. You say, okay, you know, and you can make a map based on this, you know, or label it. That's another thing. You can go to labels, and this is all under the layer properties. Under that individual layer over here in the table of contents. So you have to make sure that you click the label features. Otherwise, everything you manipulate in here will not actually show up on your map. So we'll do land use again, and then we'll say we can keep that the same, but I'll make it bigger so you can actually see it. Say okay. So now you've got this on here, and you could use that, you know, to make a map. This is not the prettiest thing ever, but you get the point. You got a lot of options here to use this information. Either it's just for your design folder, or you're trying to present something to somebody. And this doesn't have to be just for waterways. You know, you can prove some stormwaters do things with drainage complaints. You know, you can use this to help a landowner understand how much water is coming through their property or things like that. But yeah, I think that's about it for the watershed tool. I'm glad everything ran smoothly. And that was the 2.0 version, the new version. So yeah, worked pretty good for me. Unfortunately, I know it's not going to work great for everybody, so I would probably just do the older version, which is here, and it's the same exact tools for your watershed delineation and runoff. Nothing has changed in that area. Just mostly with the tools outside of that are merge raster information. But yeah, so I'm going to turn it back over to Amy, and she's going to show you some alternative ways to do things with your soil layer or your soils in the watershed layer. So.
Okay, so obviously everyone is not always going to have the availability to get that clue layer depending on your county that you're working with. One of the things I like to do if I don't have access to that clue layer in a particular county is I like to put things into the web soil survey. Okay, are we getting feedback here? I'm getting some feedback on mine. So one of the things I like to do, and I don't think, you know what, we should probably pull Lindsay's back up here. One of the things that you need to do if you're going to put something to the web soil survey is you need to export that shape file that she had created. So in order to do that, she's showing you here, you just go, kind of getting some weird fuzziness here, but you can go and you can export that. So you're going to export data. It's going to create a whole bunch of files here, and then that's okay. And we can do double duty with some of those files that's going to create there. First of all, we can import that into our web soil survey to be able to get a breakdown of those soils. We can also take that exact same shape file and then we can put it into AutoCAD if you're using AutoCAD, and then that's going to give you your watershed map into your AutoCAD, which is required on an engineering plan.
Again, did you do a?
And again, like all GIS, it's unhappy if you don't save it exactly where it likes to go. And some days it works a little smoother than others. But anyway, once we get that data exported, it's going to create several files. And what I'm going to do is I'm often going to put this into the web soil survey because I find it's usually the fastest way to break down my different soils. So you can just start web soil survey, and we're just going to touch a little bit on what this program can do. I know next month we will end up going with Matt Lane with ODA, and he'll go very far in detail on this. But the only thing we're interested today is the area of interest and importing our area of interest. So we're going to create an area of interest from a shape file. So we're just going to click on this, and we need to be able to populate these files here. So I'm first going to go to the shape file, and I'm just going to.
Hey, Amy, we're not seeing your screen now. If you were.
Okay, well, that is a problem, isn't it? Okay, can you see my screen now?
Yes.
Yes, okay, we'll start over. So let's start with the web soil survey. Again, the only portion that we're interested in is this import AOI from a shape file, and we need to populate these boxes. So we're just going to click on those boxes, and the first one we need to do is to populate that shape file. So the first thing I usually do is stretch these out to make sure we can see everything. So you can see we have several things here to choose from. So the shape source is actually our shape file. And you can see it'll have the SHP on the end. Then we need our SHX one. Which is going to be that one right there. And it says, and then this one says it's optional, but I always go ahead and populate it anyway. And then you set your AOI, it'll zoom to where we're going to go, and you can see that it just populated that. And then at that point, we can create a soils map. And it's going to divide everything down. Now, obviously, this isn't quite as convenient as the clue layer, but at least we have all the soils separated. We know we have 3 different soils here. This is obviously going to be a lot more helpful when we don't have a lot of different land use changes, because you are going to have some hand manipulation of finding out the different land uses and the different amounts. But at least we know how many acres of each of these soils that we do have within this watershed here. So does anybody have any questions? I think it's time we will take things here. I guess if anybody has any issues running any of these programs, feel free to call myself or any of the ODA engineers. We're more than happy to help you run this if you are having some issues. No questions today.
We've got no questions in the chat, so if anybody wants to ask a question, unmute your mic or throw it in the chat. But
this is Justin, Tim. I was just going to show the first thing Amy talked about is the computer requirements for AutoCAD and ArcMap. This is a standard thing we send out everyone when they ask for what computer to get, what options to choose. The biggest difference between AutoCAD and ArcMap is the the CPU type. So for AutoCAD, it is a linear calculator, which means that it does one process after another. But when you talk about ArcMap, it's got the ability to do multiple processes at once. So on this list here, when I first came out with it, I said the number of cores do not matter for AutoCAD, which is true. But when it comes to ArcMap, the more cores you have, the better. So, and obviously the more expensive. So just keep that in mind, that if you are going to run ArcMap quite a bit, you probably do want to up for the larger amount of cores for the CPU. But pretty much everything else from there is the same. And if, like Amy said, if you got any questions on what computer to order, don't hesitate to give us a call or send us an email, and hopefully we can get you set up with the right kind of specs. So the other thing I wanted to point out real quick was the graphics card. Just make sure whatever it is, whether it's a gaming card or a dedicated workstation card, it's got to be a dedicated card and not an integrated card. The difference being most basic computers they have an integrated card, which means that it uses memory from the RAM, and we don't want that. We want to save the RAM for everything internally for the AutoCAD processes. So if you have a dedicated graphics card, it doesn't use up any of the RAM. It's got its own internal memory on the dedicated card. So just keep those two things in mind. That's all I had. Other than for the soil stuff, I don't have access to the clue layer or anything like that. And oftentimes up in Northwest Ohio, your curve number is going to be 85. You can do all the processes like that, but because we're so flat up here with so consistent soil types, it's normally going to be 85 or 86 or 84. So generally we spend less time on that amount, but that does not give you the green light to use that. You should still use the same process Amy showed, or if you're even better with the ArcMap, use a process that Lindsay showed earlier. So that's all I have, Tim.
Thanks, Justin. We got one question in the chat, and that is, where can the tool be downloaded from?
So the tool is actually on the NRCS website. We can post this somewhere and we can get those tools out to you. Do you have those, Tim, so you can post the 1.15 and the 2.0?
Yep.
Okay.
Well, we did have another comment about sending out the document that Justin just shared, and I'll get that out as well. But if there's no other questions or comments, that'll be it for today. Last chance. All right, well, thank you to Amy and Lindsay for presenting today. I'll get the recording for today's webinar posted up on YouTube. There'll be an announcement through the Federation email about that going out, and we'll try and get the NRCS Engineering Tool and the Word document shared as well. All right, thanks everybody.